Okay, so today we're going to find a different way to graph a line, and that's called using the intercepts. So we have the y-intercept that we talked about yesterday, which is where it crosses the y-axis. We're talking about x-intercept form, where it crosses the x-axis. Since any linear equation can be graphed using 2 points, you can use the x and y-intercept to graph an equation. So all we have to do is 2 points today, the x-intercept and the y-intercept. The x-intercept, where the line crosses the x-axis, so y will always be 0, so in the y spot will be a 0. There'll be some number in the x-axis, or in the x-coordinate. To find it, we're just going to plug 0 in for y. The y-intercept, where the line crosses the y-axis, the ordered pair will look like 0, some number, flip-flopped, because x will always be 0, and we plug 0 in for x to solve. So, on slide 2. So it says state the x and y intercepts of y equals 1.5x minus 9. I'm going to go through the work, but maybe you can actually pick out one of the intercepts right now. Then we're going to use the intercepts to graph the equation. So the x-intercept, that's when y equals 0. So 0 equals 1.5x minus 9. I'd add 9 to both sides. Get 1.5x equals 9. Divide both sides by 1.5. And I'd get x equals 6, as long as I remember my math. Double checking, and we get 6. So the ordered pair would be 6, 0. So I don't know, 1, 2, 3, 4, 5. Ooh, it doesn't quite fit. So let's go by 2s. 6, 0. Okay, to do the y-intercept, that's when x equals 0. So we would do y equals 1.5 times 0 minus 9. Well, that goes away, so we get y equals negative 9. 0 and negative 9. So that one's not going to quite fit. Let's go by 3s on this one. It's okay that both axes go by different as long as they're clearly labeled. 0, negative 9. Maybe you already knew that because this is in y equals mx plus b form. So the y-intercept was negative 9. So maybe you already knew that. But if you don't, you can always plug 0 in like that and solve. So we're still in, and we just connect the dots, put lines at the end, we're good. In this one, if you notice, we're still in y equals mx plus b form. So b, or the y-intercept, is 5. So that would be 0, 5, which we can graph that. 2, 4, 6, so 5. But to solve for the x-intercept, that's when y equals 0. 0 equals negative 1/3 x plus 5. Subtract 5 from both sides. Negative 5 equals negative 1/3 x multiplied by the reciprocal, which is negative 3. Negative times a negative is a positive, so x equals 15. So the ordered pair would be 15, 0. And then we go here. Connect the two dots. We've graphed it using the intercepts. Line or arrows at both ends, because the line goes on forever. All right. Now they're going to give us this new form called standard form. So this is a vocab word. Right, when an equation is written in this form, ax plus by equals c, where a is greater than equals 0, so it's a positive number, and a, b, and c are integers, so they are whole numbers. It is written in standard form. So a little hint, when they're in standard form, solving for intercepts is much easier than when it's solving for slope-intercept form. So to solve for the x-intercept, remember we plug 0 in for y. To find the x or the y-intercept, plug 0 in for x. The x and y-intercepts are your extreme cases. In the real world, it's as if you have 0 of one and a lot of the other, or vice versa. So we'll see what I'm talking about here in a second. So on slide 5, what I'd like us to do is solve for the x and y-intercepts. So to solve for the x-intercept and the y-intercept, I'm going to do that down here at the bottom. We plug in y equals 0 for this one. So if I look up here, if I knew that y was 0, that's going to make this whole chunk go away. So it's really as if 15x equals 1800 is the only thing that's left. If I divide both sides by 15, I would get x equals 120. So the ordered pair would be 120, 0. The y-intercept, again, this was when x equals 0, so this whole x equaling something would go away. So 20y equals 1800. Divide both sides by 20. we're going to get y equals 90. So 0, 90. So to interpret, I've got a couple sentences up here. To interpret intercepts, figure out what the x and y stand for. In this case, we're talking about khakis and jeans. Since these intercepts are our extreme cases, we would just label accordingly after that. To interpret the x at its intercept, at 120, 0, we could say, when I buy 0 pairs of khakis, because that's the y, when I buy 0 pairs of khakis, I can buy 120 pairs of jeans, 0, 120. And I still spend $1,800. Vice versa, to interpret the y at 0, 90, if I buy 0 pairs of jeans, I can buy 90 pairs of khakis and still spend $1,800. So those are our extreme cases, when we buy one or the other. So slide 6 and 7 go together. We're going to graph it up here and interpret it on the next one. Malden Middle School wants to make $4,740 from yearbooks. Print yearbooks, which are X, so that's like your hard copy yearbooks, cost $60, and digital cost $15. So the things you can see on your phone or iPad. This can be represented by $60 per print plus $15 per digital equals the amount they want to make. So find the x and y intercepts. X-intercept is when y equals 0. So remember that that would go away, and we basically would be left with 60x equals 4,740. If I divide both sides by 60, I don't remember what that answer is. I get 79. So that ordered pair would be 79, 0. And we're talking about x's, so print, actually have them going by 10. 10, 20, 30, 40, 50, 60, 70, 80, a little bit before the 80. On the y-intercept, that's when x equals 0. So if I just pretended the x's were 0, I would get 15y equals 4,740. I have to divide both sides by 15. 316. But that's y. So 0, 316. So 50, 100, 150, 200, 250, 300, 350. But somewhere between 300 and 350. Got my 2 dots. All of these are in the first quadrant because we can't have negative quantities of yearbooks or khakis or whatever else we've been talking about. Okay, so now it wanted us to interpret this from the previous slide. So the x-intercept was 79, 0, and the y-intercept was 0, 316. The x-axis were the print or hard copy, and the y-intercept or the y-axis were the digital. So basically, what we can say is if we're going to interpret these, I'm going to interpret it all in one big Mod Podge sentence. The school wants to break even. The school only wants to spend $4,740. So, in order for the school to break even, or you could say to make $4,740, they can either, let's change that, they can either sell 0 digital but 79 print, or 0 print copies and 316 digital. And that's all in order for them to break even. One more similar concept. So Mr. Davies spent $230 on lunch for his class. What a guy. Sandwiches, X, so that's what's on the x-axis, cost $6 and drinks cost $2. So it can be represented by the equation here, $6 per sandwich plus $2 per drink, spent $230. Use the x and y intercepts to graph the equation. So we need to find that. Remember, x-intercept is when y equals 0. So assuming this would go away, 6x equals 230. This is when x equals 0, so 2y equals 230. Divide this one by 6. $38 1/3. What a dumb number. And this one divided by 2. y equals 115. So this would be 38 1/3 sandwiches for 0 drinks. This would be 0 sandwiches, 115 drinks. So we're going to put that into a sentence. Oh, and we can graph it, but 38 1/3, 0, 115, a line. And actually, now that I think about making those lines, they shouldn't go on forever because the intercepts are your extreme cases and they will never go to the negative. So go back and erase your little lines on the word problem ones. On the word problem ones, the real life ones, because you can't go into negative sandwiches and negative drinks. So they don't need lines at either end. Okay. So to spend $230, he can purchase 0 drinks and 38 1/3 sandwiches, or 0 sandwiches and 115 drinks. The end. Have a great day.